Potential gradient. First, we will discuss potential difference, then potential gradient. What is potential difference? Here we have a negative charge plate and a positive charge plate, and the electric field is from positive to negative. And here we have a positive test charge Q naught. Now, to move a charge from point A to point B, we need some external force because the negative charges are attracting this positive charge and this positive charges are repelling. So, to move against the field, we need some external force. So, by applying external force, it will cover the distance from A to B. Force is applied and the distance is covered. Force is applied and the distance is covered means the work is done. Force and displacement is equal to work done. Here work is done on a unit charge. Work done per unit charge. Gives the potential difference del V. Potential at A and potential at B. Del V means potential difference between A and B. So potential difference is equal to work done per unit charge. Potential difference is the difference in electric potential between two points and is equal to work done per unit charge. So its SI units is volt, which is equal to joule per coulomb. Potential difference is measured in volt. Work is measured in joule. Charge is measured in coulombs. So the volt is equal to joule per coulomb. Its SI unit, its dimensions m L square T power minus 3 power minus 1. I'll explain in the last. Now it's a potential difference. Now what is the potential gradient? Potential gradient means change in electric potential with respect to distance. Potential gradient is the change in potential with respect to distance. Is known as rate of change of potential with respect to distance is known as potential gradient. Potential gradient is the rate of change of, as we know that, rate of change of displacement with respect to time. Rate of change of displacement is called velocity, and rate of change of velocity is called acceleration, and rate of change of potential difference with respect to distance is called potential gradient. They are same. So it's not a part of this topic. Rate of change of potential gradient is the rate of change of electric potential with respect to distance. Now, derivation for the potential gradient. Let's find the relationship between the potential gradient. Potential gradient means change in potential with respect to distance and electric field. As we know that work done per unit charge gives the potential difference, work done per unit charge gives the electric potential difference between those points. The negative sign indicates the charge is moved. The work is done against the electric field. Electric field is from positive to negative, and the charge is moved against the electric field. Negative sign indicates that the work is done against the electric field. Work is equal to force and displacement. So replace the W with force and displacement. R is the displacement between point A and point B. In previous lecture, electric field strength, we studied that the force per unit charge gives the electric field strength. So F is equal to E Q naught. Q naught will be multiplied. So by putting the value of F here, F is equal to E Q naught will be multiplied, and del and Q naught are as it is. They both will be cancelled out, and E del R and del V are left. E del R, del V, and the minus sign. Del R will be divided, multiply both sides with minus 1. E will be minus del V by del R. Del V by del R is the potential gradient. So we derive the relation mathematical. Potential gradient is equal to electric field strength. E is the electric field strength, del V by del R is the potential gradient. Negative sign. Negative sign means that the potential decreases in the direction of electric field. If we move in the direction of electric field, the potential energy decreases. For example, I'm doing work on this marker. I'm applying force and it covers distance. Force, distance means work is done on this marker. And this work is stored in this marker as a potential energy. So, now I move this marker against the gravitational electric field. This gravitation potential energy. If we move the charge against the electric field, it has electric, not a gravitation, electric potential energy, and the marker has gravitational potential energy. So if we move along the gravitational field, now it has no potential energy with respect to this dice. So same concept of the minus. If we move along the electric field, the potential energy will be decreases. The negative time means the potential energy decreases. In the direction of the electric field, against the electric field, the potential energy increases. Units. Unit of potential gradient is the potential difference is measured in volt, distance is measured in meter. So the unit is volt per meter. Unit of potential gradient or electric field strength. Potential difference is measured in volt, distance is measured in meter. So the unit is volt per meter. Its dimension is here the derivation of for the dimensions. Now the topic is completed. It's for dimensions. As watt ampere per unit charge gives the potential difference del V. Work is equal to force or display force. Work is equal to force and displacement F dot D. Replaced the W with this, and now F is equal to MA. Put the value of F. Now A is the rate of change of velocity V by T by putting the value of A. Now the M is as it is, D that is, Q is as it is, but A is replaced with V and T. Now V is replaced with D and T. Rate of change of displacement is called velocity. V is replaced with D by T. M and T are as it is, D as it is, and Q is replaced with IT because current is equal to rate of flow of charge. So T will be multiplied and Q is equal to IT. Q is replaced with IT. Here becomes 3 T's, becomes a T cube, I is at is it, D is 2 D's, D square, M is as it is. So the dimensions of potential difference V. M is the mass, capital M, D is the distance, capital N, T is the time, capital T, A is the current, capital A. So that's the dimensions of volt, V. That's all.